In this video, we're going to look at depreciation. Just a reminder that this is part of exponential growth and decay. So remember, our general formula for exponential growth is A or Y equals KAT, which, remember, K is our initial amount, T is the time that it's depreciated or invested by, and A is our growth factor or our growth rate. Now let's just assume that we're decaying. So, for example, something that decays is the value of a car. So I'll just head straight into an example. Let's suppose you had a car and it was worth $12,500 brand new. Now, if it depreciates at a rate of 12.5% per annum, so remember that means per year, what's the car valued at after 7 years? Now, what we've got to do is use this general equation here to come up with an equation. We can see that depreciate means decay, so we're going to depreciate at 12.5%. Now, remember, something that depreciates at 12.5% per year is going to have a percentage multiplier. Now, when we use the percentage multiplier, we know that that's, say, 100% the whole value. We're decaying, so we're taking off 12.5%. So technically, we're working out 87.5% of that value, and then we're obviously going to do that to the power 7. So let's just work out what that formula is going to be. So the value is the initial amount, so that's 12,500, multiplied by our growth factor, which is going to be our decay rate, so that's 1 minus the rate, so 12.5 over 100, to the power 7. Okay, so what we have here is this is our 0.875 here, which, as we said earlier, was going to be the 87.5% worth, and that's obviously what the multiplier is. Now, if I work that out on the calculator, obviously putting that to the power 7, I get that the value of the car is now $4,908.70. So the way we came up with this formula is we looked at the growth factor, this growth rate here, or this decay rate here, which is A. And when we're depreciating, A becomes 1 minus that percent.